So first question is solute A associates in water, right? So when 0.7 gram of solute A is dissolved in 42 gram of water, it depresses the freezing point by 0.2 degrees Celsius, right? So the percentage association of solute A in water is, you have to tell me the percentage dissociation of solute A in water. And what is given here? The molar mass of A is given, which is 93 gram per mole. And molar depression constant of water is also given, which is 1.86 Kelvin kg per mole. Okay. And there are four options here: 50%, 60%, 70%, and 80%. Okay. Just tell me to solve it. How will you proceed this question? Okay, what is given here? Given here is the molar mass is given, right? Molar mass of A is given, which is 93 gram per mole. Okay. And Kf value is given. Molar depression constant is of water is given, which is 1.86 Kelvin kg per mole. And delta Tf value is also given, right? 0.2. So we know that what is the formula for delta Tf? When Kf and molality is given.
Kf into molality.
Yeah, good. And just multiply it by I factor. I into Kf into molality. Okay. Now substitute the formula for molality here. I into Kf into what will be the molality? Weight of solute upon molecular weight of solute into 1000 upon WB. Right? This was the formula for molality. Now substitute all the value in it. And yeah, this weight of solvent is in gram here. That's why we have multiplied by 1000. Now substitute all these values in this equation. 0.2, right? And your I factor is not given. And what's the value for Kf? Which is 1.86. Weight of solute is given, which is 1. Just a second. Yes, 0.7 gram of solute A is given. So just put it here, 0.7 upon 93, which is the molar mass of A component, right? 1000. What's the weight of B here? So weight of B is given 42. Now solve it and tell me the answer. What will be the value of I factor? Tell me the answer. You can use calculator also. Okay, so see, I will be equals to 6. Okay, and we know the formula for association is alpha equals to I minus 1 upon 1 upon n minus 1, right? So, and what will be the value for n? So, see, for association, when the molecules of solute form dimer, then the value of n will always be equals to 2, right? So, what will be the value of n? Here, n will be equals to 2. Now substitute the value. 6 minus 1, 1 upon 2 minus 1. You will get the value of alpha is 0.8. Okay. Now you have to find a percent association. Percent association. Right. So what will be the percent association? 0.8 to 100. Right. Which is equals to 80%. Okay. So what will be the answer? Which option is correct? So option D will be correct. 80%. Got it? Here.
Yes.
Okay. Have you written? Okay. Just write it down. Write it down. Then we will move to the second question.
Done.
Okay. Okay, let's move to the next question. Okay, so here's the second question. So the depression in freezing point is observed for a formic acid solution which is having a concentration 0.5 mole per liter, right? And the depression in freezing point is 0.040 degrees Celsius, right? So, and the density of formic acid is this 1.05 gram per ml. Okay, so you have to tell me the want of factor of the formic acid solution is, right? Okay, solve it. So see, what is the concentration of formic acid given? The concentration is 0.5 mole per liter, right? So we know that, see, so just 0.5 ml into just multiply it by its density, right? And you will get the mass of formic acid, right? 0.5 ml into 1.05. Just multiply it by its density, gram per ml formic acid in 1 liter, right? What you will get? You will get the mass over here. Mass of formic acid comes to be 0.5 to 5 gram, right? So 0.5 to 5 gram formic acid is present in 1 liter of solution. Okay, now let's find the molality of this. What is the molality? Molality is, what is the given mass? 0.525 given mass upon molar mass, right? Molar mass of this is 46, right? Molar mass of formic acid is 46 and just divided by what is the mass of solvent here? The mass of solvent here is 1 kg in per kg, right? Because see, it's a just assume it as a dilute solution, right? Because very little amount of solute is present in large amount of solvent. So it's a dilute solution, very dilute solution it is, right? Now we know that delta TF is equals to I KF into M, right? So from here you can calculate I, which is delta TF upon KF into M, right? Now substitute the value. What is the delta TF value given in the question? 0.0405 into, just a upon what is the value of Kf? So the Kf value is 1.86, and from here just substitute the molality value. What is the value for molality? 0.525 and upon 646. Now solve it. Solve this, calculate it, and you will get the value of I to be 1.9, right? So what will be the value of I? I will be equals to 1.9. So see, check it, which option is correct. Okay, so options are not given. So it's a integral type of question. So the I value is 1.9. Okay, clear? That's how you can calculate.
Yes, ma'am.
Okay, written. Just write it down. Write it down and update me.
Done, ma'am.
Okay, bache. Okay, let's move to the next question. Question number 3 it is. So in this question is given that which one of the following 0.06 molar aqueous solution has lowest freezing point? Means for all the options the molarity is same, right? 0.06 molar aqueous solution for all the options. And you just have to tell me that which option has lowest freezing point. Tell me A, B, C, or D. Which option has the lowest freezing point? Glucose, K2SO4, Ki, or Al2SO4 both has.
Ma'am, is it option A?
Option A, how?
Option D.
Option A will be correct. See how. So first, we check we'll check the number of ions for each given compound, right? And the compound which has highest number of ions will have the highest value of I. And thus we will that compound which has highest value of I, it will have the lowest freezing point. Just remember that. Just write it down. Write down this concept. The compound with highest number of ions will have highest value of I, right? Highest value of 1 to factor, and thus it will have lowest freezing point. I'm writing freezing point as FP. Okay, just remember this. So just check for which given compound the value of I is highest. How will you calculate? So for this glucose, it's a non-electrolyte, so it will not dissociate. So what will be the value for I? It will equals to 1, right? Just for K2SO4, just K2K plus SO4 2 minus. So how many ions are there? 2 plus 1, 3. So I value is 3, right? And for Ki, K plus I minus. So what will be the I value? I value is 2, right? And for Al2SO4 whole thrice, just dissociate it it will dissociate to form Al, 2Al, 3 plus 3SO4, 2 minus. So check out how many ions are there? 3 plus 2, right? So the value of I will be 5. So what I said, the compound with the highest number of ions will have the highest value of I, right? And the compound which has highest value of I will have the lowest freezing point. So which option is correct? So option D will be correct. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, good. Remember this. Okay, the next one. Okay, try this question. Question number 4. If a mango shrinks when kept in concentrated salt solution, then which of the following process takes place? Tell me. Very easy question.
C.
How?
Osmosis.
Yeah, yes. How? So we have learned that the osmosis is the process which occurs from low concentration to high concentration, right? So when mango was kept in a concentrated salt solution, the solvent, which is water, right? So solvent from mango, it will move to the concentrated salt solution. And when the solvent moves to the concentrated salt solution, consequently, mango shrinks in a solution, right? And this phenomena is osmosis, right? From low concentration, movement from the low concentration to the high concentration. So this process is osmosis. Okay. Here's the next question. Question number 5. So two solutions A and B are prepared by dissolving 1 gram of non-volatile solutes X and Y respectively. Okay, in 1 kg of water. The mass of water is 1 kg. So the ratio of depression in freezing points for A and B is found to be 1:4. So what will be the ratio of molar masses of X and Y? Option 1 is 1:4, 1:0.25, 1:0.20, and D option is 1:5. Solve it. This type of questions we can ask in JEE Mains. It's a question which has been asked in 2022. Solve it and tell me the answer. At least try it. Okay, see, bachche. So we know that the depression in freezing point is directly proportional to the molar concentration of the solution, right? So according to question, what is given here is the ratio of depression in freezing point of both the components are 1:4, right? So just put the value of TF here. So see, so what's the value for delta TF for A? AF into molality. And what will be the molality? given mass is 1 upon molar mass of A into the mass of solvent in kg. This is in kg. Just upon, what's the value for delta TF of D? So it will be KF into, again, 1 is given mass of solute is 1, and what's the molar mass of B? MB into 1 kg. This is for solvent, amount of solvent it is, and which is equals to 1 upon 4. Now see, this KF and this KF will be cancelled out, and you will get, this will cancel out, and you will get MB upon MA, which is equals to 1 upon 4. Okay, so you will get the ratio of molecular mass of A and B. Now just solve it. MA, now just reverse the reciprocal of MA upon MB, it will be 4 upon 1, and MA is to MB, you will get 4 is to 1, or you can say it will be 1 is to, just a second. Yeah. When you simplify it, you will get 1 is to 0.25. Okay, so this is the ratio of molecular mass of A and B. 1 is to 0.25. So what will be the option? Which option is correct? So option B will be correct. This is the correct option. 1 is to 0.25. Got it?
Yes, ma'am.
Okay, next question. Written?
Yes, ma'am.
Okay, let's.
Yes, ma'am.
Okay, see the next question. Here, 0.004 molar K2SO4 solution is isotonic with 0.01 molar glucose solution. Okay, so the percent dissociation of K2SO4 is, again, integral type of question. Solve it. Now see, we know that for isotonic solution, pressure will be same for both. Osmotic pressure of glucose is equals to osmotic pressure of K2SO4, right? For isotonic solution. So the osmotic pressure of glucose is equals to osmotic pressure of K2SO4, right? Now, what is the formula for osmotic pressure? Tell me.
CRT.
Yes, I into CRT, where RT is your constant, right? RT is your constant. So what will be the value? I pi equals to I into C. Okay. Now substitute this value for osmotic pressure of glucose. I into C equals to I into C, right? Now see what is given here for glucose. The I factor is 1, which is given in the question, and concentration is 0.01 molar, right? And for K2SO4, I is not given, right? I is not given, and concentration is 0.004. Now substitute these values for glucose and for K2SO4. Now substitute this value. Just a second. Let's mark it as equation 1 and substitute this value in equation 1. So what will we get? 1 into 0.01, which is equals to I into 0.004. So from here you can calculate the value for I, which is 0.01 upon 0.004, right? So what you will get is 2.5. Okay, you will get 2.5. Now see, this was the value for I. I will be equals to 2.5. Now we know that I is equals to 1 plus n minus 1 into alpha, right? Right? Are you guys there? And alpha
Yes,
is the
ma'am.
dissociation, right? So just substitute the value. The value of I is 2.5 is equals to 1 plus. Okay, tell me what is the value for n? For K2SO4, what is the value of n?
3.
Yes, good. The value for n will be 3. Just substitute the value for n. Now see what you will get. 1 plus 2 alpha. And from here you will get 2 alpha equals to 1.5 and alpha equals to 0.75. And if I say dissociation percentage in percentage form, so it will be 75%. Okay, so this is your final answer. Okay, so the percent dissociation of K2SO4 is 75%. Clear? Any doubt in this question?
No, ma'am.
Okay. Move to the next question. Yeah. So it's very interesting question. So lead storage battery contains 38% by weight. Okay. 38% solution of H2SO4. And the Wanto factor is 2.67 at this concentration. And the temperature in Kelvin at which the solution is in the battery will freezes, right? So basically they have asked the freezing point value, right? TF. You have to calculate the value of TF, freezing point temperature, to the nearest integer. And here K value is given 1.8 Kelvin kg per mole. So how will you proceed this question? Okay, see what is given here. We have weight of sulfuric acid, which is 38 gram, right? Because 38% of solution is given. So 38 gram of H2SO4 is dissolved in, what will be the weight of water? See, if 38 gram of H2SO4 is present in 100 gram of solution, 100 gram solution. So what will be the weight of solvent? 100 minus 38, right? So it will be 62 grams. So what will be the weight of H2O? Is 62 grams. Okay. Now delta TF is equals to, we know that IKF into molality. Okay. Now find the molality first. Find the molality. So it will be weight of sulfuric acid divided by molar mass of sulfuric acid into 1000 upon weight of water, which is in gram. Okay, now substitute the value. What is the weight of sulfuric acid? 38 divided by, and yeah, molar mass of sulfuric acid is 98. Okay, 2 plus 32 plus 64 will give you 98 into 1000 upon what is the weight of water? 80. No, water is not a molar mass, it's a weight. It is given 62, right? 62 grams. Now calculate it. 38,000 upon gives you 6078. Okay, you will get 6.25 molal. 6.25 molar. Okay, now substitute this value. So what is delta TF elevation in depression and freezing point will be, I is given 2.67 and your KF value is also given 1.8 and we have calculated the molality, which is 6.25. Let's multiply it. and you will get 30.04. But this is not your final answer, right? We have to find the value of TF, freezing point value, not the depression in freezing point. So just what is the formula for delta TF equals to TF naught minus TF, right? So from here, TF will be equals to TF naught, right? The freezing point of pure component and delta T. And now what is the freezing point of pure component? In Kelvin, it is 273 minus 30. 30.02 is just approximate to 30. You can take 30 only. Okay. Now subtract it. You will get 243 Kelvin. Okay. So what is the freezing point? So the freezing point, the temperature in Kelvin at which the solution in the battery will freeze is 243 Kelvin. Okay. Clear?
Yes, ma'am.
Okay. Just write it down. Write down the answer. And
Yes, ma'am.
Yes, ma'am.
okay. So let's do the next question. Question number 8. So question number 8 says a company dissolves X amount of carbon dioxide at 298 Kelvin in 1 liter of water, right, to prepare a soda water. So what is the value of X here? X equals to dash into 10 to the power minus 3 gram. Okay, and what is given here is partial pressure of carbon dioxide is given and Henry's constant value for carbon dioxide is given. So see, we know according to Henry's law, what we know is partial pressure is equals to Kh into X, right? The product of mole fraction and Henry's constant, right? So just substitute the value. What is the partial P value is given 0.835 bar, right? And Kh value is also given, which is 1.67 kilobar it is. So just convert it into bar, 10 to the power 3 bar, right? 1.67 into 10 power 3. Now substitute these values in this equation. 0.835 equals to 1.67 into 10 to the power 3 into mole fraction of carbon dioxide. Now from here you can calculate the mole fraction of carbon dioxide. So what it will be 0.835 upon 1.67 into 10 to the power 3. Okay, when you solve this, you will get, this is, yeah, when you solve this, you will get 0.005, 0.0005, which is equals to 5 into 10 to the power minus 4. So this is a mole fraction of carbon dioxide. And mole fraction of carbon dioxide is found to be 5 into 10 power minus 4, right? And we know that the formula for mole fraction is the number of moles of CO2 upon the total number of moles of all the component, right? Is equals to 5 into 10 power minus 4. Now substitute the value over here. So how will you calculate the number of moles of carbon dioxide? This is given mass of CO2, W of CO2 upon molar mass of CO2 is 44 upon of CO2 plus, and yeah, what is the number of moles of water? Just find it out, because here 1 liter of water is given. 1 liter of water is given, right? So in 1 liter, how many grams? 1000 grams. So N of number of moles of water will be, what is given mass? Given mass is 1000 and the molar mass is 80. You will get 55.5, right? So just substitute the value of number of moles of water, 55.5 is equals to 5 into 10 to the power minus. Now, when you solve this question, when you solve this equation, you will get the value of weight of CO2 is equals to 1.221 gram, right? Or you can say that 1221 into 10 to the power minus 3 grams. Okay, so the mass of carbon dioxide in 1 liter of water will be 1221 into 10 to the power minus 3 grams. Okay, so what will be the value of x? So x will be this 1221 into 10 to the power minus 3 gram. Clear?
Yes, ma'am.
Okay. Okay, see the next question. So these questions are very important. Most of the questions they ask from qualitative properties only, like from freezing point, depression, elevation in boiling point, etc. Okay, so here's a question, question number 9. What is the freezing point depression constant of a solvent, 50 gram of which contain 1 gram non-volatile solute, right? And molecular mass is also given, which is 256 gram per mole. And the decrease in freezing point is 0.40. What you have to calculate is you have to calculate the value of Kb, right? Freezing point depression constant it is. What will be the value? Options are 3.72, 1.86, 4.43, or 5.12. Solve it. Then it's very easy. What is given in the question? So delta TF value is given, which is 0.40 Kelvin, right? So what we know is delta TF is equals to Kb into M. So there is no need of I factor, right? And just substitute the value 0.4 is equals to, we don't know the Kb, right? We have to calculate the Kb and just find the molality, which is Wp given mass of solute upon molecular mass of solute into 1000 upon weight of solvent, right? Now substitute Kb. What is the weight of solute? 1 gram, and molecular mass is given, which is 256 into 1000, and the weight of solvent is 50 gram. Okay, just solve it. 0.4 into 256 into 50 upon 1000. Okay, when you solve it, when you calculate this equation, you will get the value of freezing point depression constant to be 5.12, right? So what will be the option? Which option is correct? Option D will be correct. This will be the correct option. Okay. Meera and Upsana, got it?
Yes.
Yes.
Okay, bache. See the next question. Next question is, when a non-volatile solute is added to a solvent. So the vapor pressure of the solvent decreases by 10 mm of Hg. Okay, and the mole fraction of the solute in the solution is also given, which is 0.2. Now, what would be the mole fraction of the solvent if the vapor pressure decreases by 20 mm of Hg? Again, very simple. Just remember the concept. So what is given here? When a non-volatile solute is added to a solvent, what happens? The vapor pressure decreases by 10 mm of Hg. Now see, since we know that V naught minus V, it is directly proportional to x of solute, mole fraction of solute, right? And what is the vapor pressure? Vapor pressure is decreased by 10 mm of Hg, right? So, and when the vapor pressure decreases by 10 mm of Hg, at that time, the mole fraction of the solute in the solution was 0.2. Okay. Now the question has been asked that when the mole fraction, what will be the mole fraction of solvent if the vapor pressure it decreases by 20? So as you can see that 10, it is just double, right? It's just a double 10, and this is 20. So what will be the change in the mole fraction? It will also get double, right? So it will comes to be 0.4, right? So if the mole fraction of solute is 0.4, so you can calculate the mole fraction of solvent, right? Because they have asked the mole fraction of solvent, not for solute. Just remember that. So what will be the mole fraction of solvent? Just subtract it by minus 1. 1 minus x of solute. What it will be? 1 minus 0.4. You will get 0.6 over here. So which option is correct? 0.6. See here, a 0.4 option is also given. So don't be confused. They have just asked the mole fraction of solvent, not for solute one. So the correct option will be 0.6. Okay, bachcho?
Yes, ma'am.
Yes, ma'am.
Okay. Have you written?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, let's see the next question. So in this question, if A to B, this compound is 30% ionized in a aqueous solution, then the value of want of factor I is. Just tell me the value of want of factor. For this, what you have to do is just try it once. Try it by yourself once. See, this is A2, AB2. Okay, this is AB2. Okay, first write down the ionization equation. So AB2, it will ionize to form A2 plus, right? Plus 2B minus, right? So what will be the, so initially this will be 0, 0, and for this it is 1. Okay, what is the degree of ionization here? Alpha, and for this is for 2 alpha, right? 2 alpha, and for this it is 1 minus alpha, right? So just for I factor, we know that it will be 1 minus alpha plus 2 alpha. You will get, this will cancel out and you will get 1 plus 2 alpha, right? So 1 plus 2 alpha, which is equals to, just substitute the value for alpha. 1 plus 2 into, so what is given here is 30% of ionized, right? It means what's the value for alpha is, it is in percentage, but alpha will be 0.3, right? 30 upon 100, it will give you 0.3. So just substitute the value of alpha, 0.3. So you will get 1 plus 0.6, which is equals to 1.6. And you can also write it as 116 into 10 to the power minus 1. Okay, 16 into 10 to the power minus 1. So what will be the value? 16. See, is here into 10 to the power minus 1 is also given. So what will be the value? 16. The value for one-to factor is 16 into 10 to the power minus 1. So that's how we can calculate for the one-to factor of the given compound. First, write down the ionization equation. Then, after that, calculate the one-to factor like this. Clear? Is there any doubt?
Clear, ma'am.
Okay, so this is the last question, Bacho. It is what happens to the freezing point of benzene when a small quantity of naphthalene is added to benzene? When a small amount of naphthalene is added to benzene, what happens to the freezing point of benzene? Just tell me. We have done it yesterday. It increases when we add,
Decreases.
yes, it decreases. When we add a solute to the solvent, what happens? The freezing point decreases, right? What will be the option? Decreases. On addition of naphthalene to benzene, there is a depression in freezing point of benzene, right? You will show the depression in freezing point of benzene. So the option D will be your correct. Okay. So that's the question, previous year questions, which has come in your JEE exams. That's very important. And please practice more questions, more previous year questions based on these chapters like colligative properties and your want of factor, Henry's law. These topics are very, very important for your JEE mains. Okay. Now, let's uh, let's do some intro of the your next chapter, which is a chemical kinetics. Right, we will start the chemical kinetics in the next section. But before that, there will be an intro. See, just a second. chemical kinetics. So this is the second chapter, right? We have finished the first one. We have done discussed lots of previous year questions. Is there any problem in the first chapter solution?
No, ma'am.
Everything is clear, right? So please practice as much as you can. Practice more questions based on that. Uh, and today we are going to start the chemical kinetics. So what are the scope and importance of kinetics of reaction? Tell me, anyone?
To
What
find the
we
rate of a reaction.
Yes, so in kinetics, we study the rate of chemical reaction, right? Along with the course of all physical and chemical processes which are induced during the reaction. And and it is helpful in finding the conditions to maximize the yield of products, right? So that we can maximize the yield of products. And what are the classification? We will do the theory part. After that, we will cover the numericals based on that, right? First, see the classification of reactions on the basis of rate reaction. Basis of rate of reaction. So what are the classifications? So first one is very fast reaction, right? So the reactions, first one is your very fast reaction. Second one is your very slow reaction. Reaction can be very slow. Or another one is your slow or moderate reaction. Okay, now let's see. Let's have a look one by one. So, what are very fast reactions? So, very fast reactions are the reactions that involves ions, right? Which proceed so rapidly that they may be practically considered instantaneous, right? Very fast reactions are also known as instantaneous type of reactions because they are very rapid. For example, neutralization of a strong acid and a strong base, right? These are instantaneous type of reaction, which is very fast reaction, rapid reaction. Okay. Okay, see the next one, very slow reaction. So this type of reactions proceed very slowly and they may take even several months for their completion, right? For example, very basic example is rusting of iron. It will take very several months for their completion, right? It is very slow. Okay, the third one is slow or moderate type of reactions. So this type of reactions are neither very fast nor very slow, right? They this type of reaction are those whose rates can be measured conveniently, right? We can conveniently measure the rate, and that's why they are called slow or moderate type of reaction. Like for example, hydrolysis of ester. Best example is hydrolysis of esters. When do hydrolysis of esters? Well, it is a slow type of reaction. Okay, clear?
Yes, ma'am.
Okay. Okay, now see the reaction rate and factors affecting the reaction rate. So what is the rate of reaction? If I say rate of a chemical reaction, what does it mean? How will you define the rate of reaction? So see, the rate of a chemical reaction, it can be defined as the change in concentration. When wherever we use rate term, it means the change in concentration with respect to something, right? It means the change in something with respect to something. The rate of a reaction is defined as a change in concentration of any of the reactant or product per unit time, right? With respect to time, like, see, concentration, like I'm using D, concentration upon dt. So we can define the rate of reaction like this: the change in concentration with respect to time. Okay. And what are the unit of rate of reaction? Tell me. Units. No. So see, the unit of change rate of reaction will be either mole per liter per second, or you can use atm per second. Okay. So when the reactants and products are in gaseous state, right? When the products are in gaseous state. Okay. Okay, bachcho. So, in the next class, we will uh, continue the chemical kinetics. We will study about the average rate of reaction, instantaneous type of reaction, and the factors affecting the rate of reaction, right? Like the nature of reactants, how it is affected by the concentration of reactants, like temperature, how the temperature in whether the temperature rate increases with increase in temperature or decreases with decrease in temperature, right? And about the presence of catalyst, its surface area, we will see in the next session. Okay, we will cover these topics in the next class. Okay, Bachu. So was the session uh, informative? Was it helpful?
Yes, ma'am.
Okay,
Yes, ma'am.
please practice more questions based on this. And if there is any doubt, please ask the questions in the next class. Okay.
Okay, ma'am.
Okay. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Okay, you can.